Guys, welcome back to my channel. I am Rakshita, currently pursuing BE in Shri Venkateshwar College of Engineering, Department of Electronics and Communication. My USN is 1VE22EC090. Subject is control system. On today my topic is block diagram reduction technique. Introduction to block diagram reduction technique. Block diagram reduction technique is a method used to control system to simplify complex system by reducing the number of blocks and improving system performance. This technique involves combining blocks, eliminating redundant blocks, and arranging the remaining blocks in the way that makes the system easy to analyze and understand. By applying block diagram reduction, engineering can optimize system design, reduce complexity, and enhance the system stability. How program statement of complex control system. Consider a control system with multiple interconnection blocks that makes analyze and troubleshoot challenges. This complexity of the system makes it difficult to identify the relationship between input and output affects overall system performance. The system requires the systematic approach to simplify the block diagram and improve its functionality. How to identify the reducing blocks. Starting by identifying reducing blocks in a system that can be combined or eliminated with efficiency the overall functionality. Looking for the feedback loops and loops that can broken into simplify the system. Identifying blocks that can rearrange and improve the flow of information and make the system more efficiency. Application of block diagram reduction techniques. There are some applications that to reduce the block diagram reduction techniques. Using this technique such as algebraic multiplication, signal flow graph, and Mason-Gain formula to simplify the block diagram. Combining serial and parallel block to reduce the number of blocks in the system. It combines both serial and the parallel blocks to reduce the number of blocks in a system. Eliminate unnecessary loops and feedbacking path to streamline the system and improve stability. Unnecessary loops is been removed and feedback path of streamline the system and improve stability. As you can see, this is a block diagram reduction example, how the block diagram has been and how further steps how it will be reduced. Solution: simplified block diagram. After applying block diagram reduction technique, the complex control system is simplified into more magnifiable and understandable form. This simplified block diagram helps engineering analyze the system more efficiency and make information decided for the system optimization. By reducing this complexity of system, overall performance and the stability are improved. Benefit of block. What is the benefit of the block diagram reduction is block diagram reduction technique helps engineering optimize system design, reduce complexity, and improve system performance. Simplifying block diagram makes it easy and troubleshoots and debug the control system and saves the time and the resources. By applying block diagram reduction, engineering can enhance the system stability and ensure efficiency operation. It consumes a consume of time is less and it debugs the control system and it simplifies the block diagram. Example: this is example problem solving problem on based diagram reduction of following block diagram using this block diagram rules. This is the problem. Now how we can solve, let's see. Step 1: G1 and G2 are connected in parallel. As you can see here, G1 and G2 are connected in parallel, so it will be plus sign. If it is if it is parallel, it will be a plus sign, as you can see here, where the G1 and G2, G1 plus G2 it became. Next step, eliminating the summing point before G1 plus G2 having negative feedback H1 is closed loop system. As you can see, where G1 and G2 have a negative feedback, where H1 is a closed loop system. So we are adding this G1 also, where it becomes G1 plus G2 by G1 plus G1 1 plus G1 by, as usual, G1 plus G2, as you can see this block diagram as I showed here. Step 3, moving summing points after G4 to become G4. As you can see here, where G3 and G4 becomes the summing points, where G3 and G4 gone up with G3, as you can see in this block diagram. They both are summing points. Summing points come together. Exchanging the positive of both the summing points before G4. Exchanging the positive of both, where this both are positive sign of summing points before G4, as you can see here in this block diagram, how the exchange of the positive of the both the summing points before G1. And G3 G4, as you can see, G3 G4 and G1 plus G2 by G1 plus G1 plus G1 H1 plus G2 H2, both blocks are connected in parallel. As you can see, they are all connected in parallel, so we'll equilibrate blocks. So they are equilibrium blocks because both are connected in parallel. Step 4, eliminating summing points before G4 having negative feedback in closed loop system. In closed loop system, G4 having negative loop, so we should eliminate it. So we'll get as G4 1 plus G4 by 2, as you can see here. In the after equilibrium both the cascade blocks, single block diagram represents as you show. When we cancel the both, when we do the equilibrium on the both of the cascade block, it will become the single representation, as you can see here. This became the single representation of blocks. This is example for the block diagram reduction. At the last but not the least, conclusion. Block diagram reduction techniques are essential tools to control system engineering for simplifying complex system and improve information. By identifying redundant blocks and rearranging the system and eliminating unnecessary loops, engineering can streamline control system for better functionality. The systematic application of block diagram reduction techniques leads to optimized system design and ensure the overall system performance. Thank you guys. Please do like, share, subscribe.